Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, you will learn about graphing parent functions using table of values. So the entire video about graphing parent functions will be divided into two parts, and this is going to be the first part. Alright, so before I jump straight into the very first example, what is parent function? Well, actually, parent function is an equation in the simplest form of a family of functions. In other words, parent functions are functions that do not have or do not involve any transformations. Parent functions act as foundational model in order for us to understand other related functions. Alright, so let's take a look at example 1. We have here the parent function, and some of you, I'm very sure that you are familiar with this type of function. So we have linear function, and you see the degree of the x variable is 1. And for linear functions, we don't have any restrictions for the domain or the set of x values, because any x values will actually be acceptable. Okay, so it could be negative real numbers or 0 or positive real numbers. That will be fine because the result will always be a real number. All right, now I mentioned earlier about using the table of values. So using table of values whenever you need to graph a certain function is actually the safest way, especially if you don't have any background or any idea how the graph looks like. So using table of values will be your go-to method. All right, now there are a couple of things that you need to remember whenever you use table of values. Okay, specifically for example 1. So this is a linear function, and technically the graph will be a straight line. So one thing that you need to remember is, for a linear function, in order for a line graph to appear, well, you need at least 2 points. You know that x variable is independent variable, and that only means that you can assign any values of x that you want, while y is the dependent variable. All right, whatever value you assign for x, definitely there will be a corresponding value for y. We need to choose values for x. We need to assign values for x. So normally what we do is we need to at least have a negative value, and then 0, and then positive value. But not all the time this thing needs to be applied, because it will always be dependent on what function are you graphing. Okay, so later on we will go through other different types of parent functions. As long as x is an element of real numbers, definitely you're gonna be good. All right, so for this example, I would like to use, let's say our x is -3, and then we choose 0, and then 1 positive. So let's choose 4. So now, if x is -3, so you just plug in the value of x to the given function. If x is -3, definitely y is also -3. If x is 0, so replace x by 0, and y will be 0 as well. Replace x by 4, definitely y will be 4. And now these are the sets of points that we need to plot on the Cartesian plane. So the very first point, the very first set will be -3, -3. And that point is here, 0, 0, or the origin. And the origin is here. That's the intersection of the x-axis and the y-axis. And the last set will be 4 comma 4. And 4 comma 4 is here. Connect the points for us to see the line graph. So let's move on to example number 2. All right, so for example number 2, this is another parent function. And as you can see, the degree is 2. And this function is quadratic function. And maybe some of you are familiar with how the graph looks like for quadratic function. It's a parabola. We have here the x-axis and the y-axis. And so for this example, I would like to use 5 different values of x. So I want to choose -2, -1, then 0, and then the positive counterpart of the first two, which is +1 and +2. All right, so same thing. What we need to do is to plug in the value that we assign for x to the given function. So this is the original function. So if x is -2, we replace the x by -2 and simplify that. So -2 squared is +4. Same goes for the second one. If x is -1, definitely y will be +1. If x is 0, 0 squared is 0. So 1 squared is 1 and 2 squared is 4. You can see the values right here. There's a pattern. Because maybe some of you have learned that parabola, we have what we call the axis of symmetry, in which the parabola or that symmetry divides the parabola into 2 equal parts. Let's plot the points. So first set will be -2, 4. Second set will be -1, 1. We have the origin 0, 0. We have 1, 1 and 2, 4. All right, so the first point is -2, 4, and that point is here. So -2 and then 4 up. So if you need to refresh about how to plot points on the Cartesian plane, you can watch my previously uploaded video about plotting points on the Cartesian plane, and I will paste the link in the description box. All right, so the second point that we need to plot is -1, 1, and that is here. Third point, the origin 0, 0, and then like what I told you here, the y-axis serves as the axis of symmetry, so x equals 0, vertical line, so that divides the parabola into 2 equal parts, or I should say that serves as a mirror line, this point reflected across the y-axis. Just connect the points and you will see the parabola. Sorry, the graph is not perfectly drawn. All right, so that's the parabola. So if you think that the examples I discussed so far are interesting, so give me a thumbs up. And if you haven't subscribed yet to my YouTube channel, hit the subscribe button and the notification bell so that you won't miss any of my future videos. All right, so let's head on to example number 3. All right, example number 3, you can see the degree of x is 3. This is a cubic function. All right, so same with linear and quadratic. Cubic doesn't have any restriction on the domain, or I should say any values of x that you put in here will be okay, as long as they are real numbers. For this example, I would like to use the same set of values that I used for example 2 for quadratic. So x, 2, -1, 0, +1, and +2. So same process that we need to do. If x is -2, just plug it in here. So y equals x cubed. So if x is -2, so we'll have -2 times -2 times -2. So y will be equal to -8. And if x is -1, -1 times -1 times -1 is -1. If x is 0, then y will be 0. So again, here, so 1 cubed is 1. 2 cubed is 8. So we have the sets of points that we need to plot. So the first set will be -2, -8. Second one, -1, -1. Then the origin. Then you have 1, 1, and you have 2, 8. So the first point is -2, -8 is here. Second point, -1, -1 is here. And then you have the origin, 0, 0. You have 1, 1. Then 2, 8 here. So that's the graph of y equals x cubed. All right, let's take a look at example number 4. So I'm pretty sure some of you are familiar with this function, and we call it the square root function. So unlike the first 3 parent functions that we graph, for square root function, there is a restriction here. There is a limitation here when it comes to the values of x, or what we call the radicand. Okay. So the radicand for square root function cannot be negative. The reason why is if the radicand is negative and it's a square root function that you're dealing with, definitely the answer will be an imaginary number. The values of x will be greater than or equal to 0. So we cannot select value of x that's negative. So we start from 0, and then we pick 1 for x as well, and let's pick 3 and then 4. If x is 0, so square root of 0 is 0. If x is 1, square root of 1 is 1. Now, if x is +3, square root of 3 is 1.73. And then if x is 4, square root of 4 is 2. All right, 0, 0 is here, followed by 1, 1, 3, 1.73, so somewhere here. And if x is 4, then y is 2 here. So that is the graph of y equals square root of x. And on to our last example. So we have here a cube root function. So unlike square root function, cube root function doesn't have any restrictions for x. The x value can be negative, or I should say the radicand can be a negative value as long as x value belongs to real numbers. Okay, whatever value of x you plug in there, whether it's negative or 0 or positive, definitely you will always have an answer of real number. So for this example, I would like to pick x values of -8 for the first value, followed by -6, and I want to pick 0 as well, then the positive counterparts of these two, 6 and 8. So if x is negative 8, we plug in. So y equals cube root of x. So if x is negative 8, so cube root of negative 8 is negative 2, right? Because negative 2 times negative 2 times negative 2 is negative 8, which is the opposite process. If x is negative 6, then so it's approximately negative 1.8. If x is 0, then y is 0. And if x is positive 6, then you'll have positive 1.8. And if x is 8 or positive 8, then y will be positive 2. So first point is negative 8, negative 2 is here. Followed by negative 6, negative 1.8. And then 0, 0 here. And 6, 1.8 here. 8, 2 will be here. It must be a curve, not a straight line. Alright, so that is the graph of y equals cube root of x. Alright guys, so that's all for this video. If you think that this video is insightful, give me a thumbs up. And you can also share the video. And if you haven't subscribed yet to my YouTube channel, please do so. It's Math Hub by Mr. H. Alright, once again, thank you for staying until the end of the video, and I will see you in the second part of this video.